Hey everyone, and welcome. Buckle up, because today we're taking a deep dive into the fascinating world of physics simulations.
Yeah, we're going to be looking at a website that lets you get hands-on with some pretty fundamental physics concepts.
So the site we're exploring is called Open Educational Resources, Open Source Physics at Singapore, and
It's honestly amazing.
it really
It's
is.
just packed with all these interactive simulations.
And for this deep dive, we're going to zero in on one in particular called the Primary Kinematics, or Moving Car 1D JavaScript HTML5 applet simulation model.
Catchy title, right?
Yeah, a little bit of a mouthful, but I promise it's way more fun than it sounds.
Oh yeah, for sure.
So tell me, what is it about this specific simulation that makes it such a great tool for learning?
Well, it really demonstrates just how powerful simulations can be when it comes to understanding physics. Instead of just reading about kinematics in a textbook, you actually
Right.
get to experiment with it, see how different things affect the motion of an object.
I love that it takes something that can seem so abstract, and it makes it
Yeah.
real and tangible.
Exactly. And this simulation in particular is great for visualizing all the different types of motion.
Oh, yeah.
So you can play around with a car at rest, a car moving at a constant speed, or a car that's accelerating, and then you can see how all of those different scenarios actually play out.
And it's not just the visuals either, right? I
Right.
mean, it also lets you display graphs,
Oh, yeah, definitely.
like displacement time and velocity time graphs, which
Yeah.
could be super helpful for understanding how those concepts all relate to each other.
Yeah, those graphs can be kind of hard to wrap your head around just from reading about them in a textbook. But
Yeah.
when you can actually see them changing in real time as you're like manipulating the car's motion,
Right.
it just clicks so much better.
Makes it much more clear. And I noticed that the simulation actually has some specific learning goals outlined on the website. What are those?
So basically, it's all about helping people grasp the relationship between displacement velocity and acceleration and how you can represent those things graphically. And they even encourage the use of what they call progressive mathematical models to describe how the car moves in all those different situations.
Progressive mathematical models. That sounds
I know, right?
kind of intimidating.
It's actually not as complicated as it sounds. It just means they're using different equations to describe the car's motion depending on what's happening.
Okay.
So for a car at rest, the equation might be as simple as, x equals 0 because its position isn't changing.
Right.
But then if the car's moving at a constant speed, it might be something like x equals 1 times t to show how the car's position, which is x, changes over time, which is t.
So you're actually seeing the connection between that movement of the car on the screen and a mathematical formula that represents it.
Exactly. And when the car's accelerating, it gets a little more complex.
Right.
Like x equals 0.5 times 1 times t squared. And that reflects how the car's position is changing over time when it's speeding up or slowing down at a steady rate.
So it's taking these equations that can seem so abstract and then helping you understand what they actually mean.
Exactly. And what's really cool is that the website goes beyond just providing the simulation.
Oh.
They also give you suggestions for how you could teach this stuff. Like there's something called the mystery technique.
Okay.
And then there's the little professor, little teachers approach.
Those sound intriguing. Tell me more about those.
Okay, so the mystery technique is where you present students with like a motion scenario,
Right.
and they have to figure out what equation would describe that motion. It's kind of like a puzzle,
I like that.
and it gets them thinking critically about that relationship between, the movement and how you would represent that mathematically.
Yeah, that's really cool. What about the little professor, little teachers technique?
So with that one, students work together in groups.
Mm.
Each group focuses on a different type of motion.
Okay.
And then they become like the experts on that type of motion, and they get to teach it to the rest of the class.
I love that it's promoting collaboration. It's
Yeah.
getting them to really own what they're learning.
Exactly. And speaking of the website itself, I have to say when you first go to it, it can seem kind of chaotic, but that's honestly just because they have so much stuff there.
Yeah. It's like stumbling into this workshop
Mhm.
that's just crammed with all these different tools and projects.
And there's a lot to unpack. So there's a section called Family of Resources,
Hmm.
and it links to simulations for different levels of education.
Oh, wow.
So whether you're teaching primary school, secondary school, or even junior college, there's something there for everyone. And they even link out to similar resources on other websites like the Physics Classroom and the Physics Aviary.
They really seem dedicated to making physics education as accessible as possible.
Definitely. And it doesn't stop there. They also have worksheet and video sections
Oh, wow.
with more learning materials to go along with all the simulations.
It's like a one-stop shop for interactive physics learning.
It is. And while I was browsing, I also noticed a section called Project Related.
Oh yeah, what's that all about?
So that's where they talk about the research they're doing on using open source physics simulations like this one for conceptual instruction.
So they're not just developing these simulations, they're also studying how to use them effectively. That's really impressive.
Yeah, it shows you how committed they are to really pushing the boundaries of physics education.
I'm so blown away by just how much they offer on this website. I'm sure our listeners are eager to check it out by now.
Oh, yeah, definitely. And we'll be sure to include all the links in the show notes.
You definitely don't want to miss this. It's an amazing way to learn about physics in a fun and engaging way. But before we send you all off on your physics adventures, let's just take a moment to recap what we've discovered so far.
Okay.
Okay, so we've been geeking out about this awesome website filled with physics simulations. But I'm curious, what's the big takeaway here for our listeners? Why should someone who's not like a physicist or a teacher care about this?
You know, that's a really good question. And I think the main point is that learning about physics, even something like kinematics, which can sound kind of dry, it can actually be fun and engaging.
Yeah, I think you're right. We often forget that learning can be enjoyable, especially when it comes to subjects that maybe we didn't love so much in school.
Yeah, and that's where these simulations really come in. They give you a way to interact with these concepts, like directly to experiment, to see what happens in real time. It's so much more active than just sitting there reading a textbook.
Yeah, it's like the difference between reading about how to ride a bike and actually getting on a bike and trying it yourself.
Exactly. And this primary kinematic simulation, while it focuses on these fundamental concepts, it can really spark an interest in physics. It gives you that foundation for understanding these more complex ideas later on.
It's like opening a door to a whole new world of exploration. You start with the basics of motion, and who knows where your curiosity might lead you.
And the cool thing is this type of interactive learning is becoming more and more accessible. You don't need a fancy lab or expensive equipment to explore these concepts.
Right.
All you need is a computer and an internet connection.
It's really democratizing science education. And you touched on something earlier that I wanted to come back to. You mentioned that the people who created this website, they're also doing research on how to use these simulations effectively in education.
Oh, yeah. That's one of the things I find so fascinating about this whole project. It's
Yeah.
not just about providing these cool simulations. It's about actively figuring out how they can make learning better. They're exploring different teaching techniques, studying how students actually use the simulations, and looking at the impact on their understanding.
So it's like they're taking this scientific approach to improving science education itself.
Exactly.
It seems like they're really at the forefront of innovation in this field.
Oh, absolutely. And their work could totally change how we teach and learn physics in the future. Imagine classrooms where these interactive simulations are just seamlessly integrated into the lessons.
That would be amazing. Instead of passively listening to lectures, students could be actively engaged in, exploring scientific concepts, conducting virtual experiments, testing out their hypotheses, all in a safe and stimulating environment.
Exactly. And this open educational resources, open source physics at Singapore website, it's like a little glimpse into what that future could look like.
Yeah, it's so exciting to think about all the possibilities, but for now, let's bring it back down to earth. What's one thing that our listeners could do today if they're intrigued by all of this?
I would say go to the website and try out the primary kinematics simulation yourself. Play around with it, experiment with different settings, see how the car's motion changes when you change things.
It's such a fun and educational way to spend an afternoon. And while you're there, I challenge you to go beyond just watching what happens on the screen.
Yeah, what do you mean?
Don't just passively observe the car moving.
Mm-hmm.
Engage with it. Actively ask yourself questions.
Oh, like what makes the car move in the first place?
Exactly. Or what makes it speed up or slow down.
Yeah.
And then don't be afraid to test out your ideas. Change the variables, see what happens, and check if your predictions were right.
It's all about turning learning into this process of discovery, like a playful exploration.
And as you're digging deeper into this simulation and thinking about those why questions, you're actually starting to move beyond just kinematics and into the world of dynamics.
Oh, that's a good point.
Dynamics is all about understanding the forces that make things move. And it's a really cool area of physics to explore.
It's like leveling up your understanding of how the universe works.
Exactly. You start with the basics of how things move, and then you can dive into the forces that control that movement. It's a journey that can help you appreciate just how elegant and complex the physical world really is.
And who knows, maybe this will be the thing that sparks a lifelong love of physics for someone. Maybe they'll be inspired to create their own simulations or contribute to the awesome work that the creators of this website are doing.
It's all about fostering that sense of wonder and curiosity, that desire to understand how things work. And while we've been talking a lot about the educational side of this simulation, I think it's important to remember that it's also just plain fun.
Oh, yeah, definitely.
These simulations can be so entertaining to play around with, even if you're not trying to learn something specific.
It's like a digital playground for physics enthusiasts.
You can experiment, tinker, and just enjoy the process of discovering new things.
And sometimes that's all it takes to get someone hooked on a subject, you know? That playful engagement can lead to a deeper understanding later on.
So whether you're a student, a teacher, or just someone who's curious about the world, I highly recommend checking out this website and playing around with the primary kinematics simulation.
It's a fantastic resource that really embodies the power of interactive learning. And as you're experimenting and learning about kinematics and dynamics, remember to keep asking questions, keep trying things out, and most importantly, have fun.
As we wrap up our deep dive into these interactive physics simulations, I don't know, I'm just feeling kind of amazed by it all.
Yeah, me too. It's really inspiring to see how people are using technology and creativity to make learning more engaging and accessible for everyone.
This open educational resources, open source physics at Singapore website is a perfect example of that.
Hmm.
Like they didn't just create these simulations, they went the extra mile. They're researching how effective they are and providing tons of supporting materials.
And what I find really exciting is how this whole approach can empower learners of all ages and from all different backgrounds.
Absolutely. It's not about being stuck in a classroom with a textbook anymore. Anyone with an internet connection can explore these concepts, experiment, and make discoveries at their own pace.
It's all about encouraging that love of learning, that sense of wonder and curiosity about the world around us.
And that's really what we hope you take away from this deep dive.
Mm.
Little spark of inspiration, a desire to keep exploring, and a new appreciation for just how beautiful and complex physics can be.
And we've only just scratched the surface of what's possible with interactive simulations. As technology keeps evolving, I can only imagine the amazing learning experiences that are out there waiting for us.
It's an exciting time to be a learner, and we really encourage everyone to embrace those opportunities. Explore, experiment, and never stop asking questions.
So as we wrap up this episode, I want to leave you with one final thought.
Okay, I'm listening.
Remember that physics isn't just about all those formulas and equations. It's about understanding the fundamental principles that govern how our universe works, from the tiniest particles to the largest galaxies.
And when you understand those principles, it gives you this deeper appreciation for how interconnected everything is. That intricate dance of matter and energy that makes up our reality.
So next time you see a car driving down the street, a ball flying through the air, even just a leaf falling from a tree, take a moment to appreciate the physics that's happening right in front of you.
Think about the forces, the motion, the way energy is transforming right before your eyes.
Because physics isn't just something you learn in school, it's the language of the universe, and it's always talking to us.
Thanks for joining us on this deep dive, everyone. We hope you've enjoyed the journey and that you'll continue to explore the incredible world of physics.
Until next time, keep learning, keep questioning, and keep that spark of curiosity alive.